Welcome, everybody. Thank you for joining us this evening. We are here for a Sea Level Rise Committee community conversation, exploring the LOMR process, letter of map revision for FEMA flood map changes to benefit flood insurance rates. For those of you who don't know me, my name is Gabe McPhail. I work in the Vinyl Haven Planning and Community Development Office, where I facilitate committee and town projects. Andy Dorr, town manager, is with us this evening and will be sharing with us as well as participating in the Q&A. I'm also joined behind the scenes tonight with my colleague, Matt Jablonski. Matt is our Island Fellow who's currently working for the town of Vinyl Haven. So before we jump in tonight, I just want to go over some quick Zoom etiquette. Those of you who are joining us in the Zoom room, here are a few tips and guidelines. First, that we ask that you stay on mute unless you are speaking. And if there's anything distracting going on in the background, we ask that you keep your video off. If you lose your connection because of the wonky internet, Matt is going to put a phone number and meeting ID in the chat. And you can always call in if the internet connection is bad. If you do call in by phone, you can use *6 to mute and unmute. Feel free to rename yourself. If the Zoom name that is showing up for you is not what you want to be called, go ahead and rename yourself and feel free to add anything else that's relevant, your affiliation, pronouns, etc. And if you have any Zoom issues tonight while you're in the Zoom room, you can message Matt in the chat, and Matt's email is also on the screen, so you could email him, and he's also going to put that in the chat. So to keep things streamlined tonight, we're going to use the Facebook comments feature and the Zoom chat feature to collect your questions in advance. So throughout the presentation, we encourage you to put your questions in the chat box or again in the comments box if you're joining us on Facebook. And once we get to the Q&A portion of the evening, we'll take those written questions first, and then toward the end of the conversation in evening, we'll open up to taking verbal questions that come up, or if you haven't gotten a chance to ask, or there's a reason why it's not working for you to use the chat. So there will be time to take verbal questions in the end. So I'm going to just give a quick overview of the evening. We will be looking just at a little background to sort of see how we've gotten here on our journey with the FEMA flood maps. Nathan Dill, our guest, will then be presenting us with an overview of the LOMR process, and then we'll move into our Q&A. So before I turn it over to Andy, I just want to introduce our guest presenter tonight. Nathan Dill is a coastal engineer and project manager with Ransom Consulting, LLC. Nate's expertise is applying computer models to problems in the coastal environment. In 2018, through a Coastal Communities grant, he worked with us to generate a sea level rise and storm surge analysis for the downtown area. The resulting report, Vinyl Haven Resiliency Planning Adaptation Options Recommendations, what we like to refer to as the Ransom report, provided many of the detailed recommendations that the town is now using to plan for infrastructure resiliency. Nate's knowledge with state of the science modeling and statistical techniques enables him to help clients like us better understand the risk of coastal flooding. This work includes revisions to improve flood maps, near real-time forecasting of hurricane storm surge, and modeling studies to help communities like Vinyl Haven plan for changing flooding risk in future climates. Nate graduated from Bowdoin College in 2002 and received an MS in Civil Engineering from the Louisiana State University in 2007. I'm gonna turn things over to Andy now to present us with a little background before we turn it over to Nate.
Thanks, Gabe. So just a quick, I think some of you might be aware of some of this history here, but just a quick overview of this. So back in 2014, the FEMA released its preliminary flood maps. And so that brought with it a lot of proposed changes. And the town ultimately ended up adopting those, the final maps in 2016. Some property owners during that review period did file LOMAs. There wasn't too many of them. I think a lot of it was just the extent of the changes and trying to wrap your heads around what it meant for each property owner. So again, only a couple of people that I know of took advantage of that review period to file LOMAs. At about the same time, the sea level rise committee was appointed by the select board, and then shortly after they were created, Ransom Engineering worked with us on a study to identify the flood probability, which was really to kind of help us understand timelines on capital improvement projects and some other things as we look to figure out what it is the community does in preparation for the inevitable sea level rise. So again, many efforts. There's a lot of different ways to look at this. Most of the efforts from the committee has been focused on resiliency, flood mitigation, and adaptation options. But the flood rates and maps is something that's always been on the radar as well. After numerous talks and having guest speakers come and present to the community, the selectmen wanted to understand a little bit more about the likelihood of revising the maps, specifically in the downtown area. I don't know, Gabe, if you want to change to the next slide at this point. So just, if you haven't seen the maps before, I know this isn't a great visual of the maps, but each of those squares is its own unique map that you would zoom in on, you'd be able to see the properties. And so in looking at Main Street, through some of the projects we were working on, acknowledging that the north side of Main Street where the pond is especially, it looked like there could have been some errors, didn't quite make sense while some of that lined up. So in 2020 or last year, we had asked Ransom to kind of give us a quick review or preliminary review and an opinion on their take, as they've, as a company, have been working with other communities to file LOMRs. And so with that came a memo that we presented to the select board, which brings us here today. And so tonight we wanted to give a chance to hear from Nathan of Ransom Engineering and to share with what the board had gotten this summer to talk about kind of what we're thinking about for next steps. So with that, we'll turn it back to Nate.
Hello, thank you, Gabe and Andy. I'm going to just kind of jump right into this and try to share my screen. And I can get that to work. I hope you are all, yes, thanks, Gabe. I see the thumbs up. So you're seeing my first slide here. So this is a picture that Andy sent me. This is from, I believe, January 2018, where when there was a fairly significant storm at a full moon high tide. All right, so so as Gabe and Andy had mentioned, we have been looking at coastal flood hazard modeling and mapping analysis for Vinyl Haven for a few years back now, going back to the adaptation resiliency vulnerability study that we did that was supported through the Maine Coastal Communities Grant Program back in 2017, that time frame, shortly after the new flood maps came out. And then more recently, last year, we did a comprehensive review of the, across the entire town of the analysis and mapping that was behind FEMA's new flood maps that became effective in 2016. And so that just, we've kind of already seen this actually, but just this is the header from that memo. The memo is kind of dense. It's got some technical jargon in it, and hundreds of pages of calculations, where we really, the idea with that is to just kind of expose what is sort of behind the scenes in FEMA's flood mapping. You know, when FEMA does a new flood map analysis, there is a whole lot of work that goes into calculating what the water levels are, calculating what the waves are, calculating how those waves interact with the shoreline, and trying to figure out what that base flood elevation is, and that gets mapped. And I do want to really emphasize that what you have on a FEMA flood map in terms of the flood zone area and the 1% annual chance base flood elevation is a flood level and a flood area that is relatively likely to flood. When floods happen, you know, we commonly call this the 100-year flood, and that's not something that you know that you can say, you know, happens once every 100 years. You can actually have 200-year floods in the same year. We came pretty close to that in 2018, actually. The idea is that on average, over a long period of time, assuming that there's no climate change in FEMA's case, what is the flood that has that 1% chance of occurring? We see all the time that when floods do happen, they tend to be more severe than that. So you know, just want to be really, you know, emphasize the point that flooding happens outside of the 100-year floodplain, and it can, you know, and it can be very devastating and damaging. But when it comes to FEMA's mapping, the mapping is designed to show that 1% chance flood level primarily for insurance rating purposes. So you know, it's also to be used, you know, for planning and development and ensuring, you know, safe building practices and things like that in these flood areas. But everybody should recognize that flooding happens outside of those areas, and as we look forward to, you know, sea level rise and climate change that might change the, you know, frequency of storms in the future, it's important to recognize that you know, in terms of planning for the future, the FEMA flood map is not sort of the end all be all. You really want to be looking at more severe events like a 500-year storm event, or, you know, and or considering what's going to happen in the future if sea level rises. And so, you know, just I wanted to kind of preface this discussion with this because we've all kind of seen in the last few years that there have been some pretty high water levels around Vinyl Haven and Carver's Harbor, just like that picture I just showed, and you know, flooding is happening in these areas more frequently. But the objective of this review is really to look at how accurately is that 1% chance level being portrayed. We don't want that to represent we don't want to have a 500-year level be misinterpreted as a 100-year level in terms of insurance ratings. So just going on here, I just put this in here because as a you know, computer modeler, numerical modeler, storm surge wave modeler, I always like to show pretty animations in presentations. So what this is showing is we did, as part of that vulnerability study, we did a simulation of the historic Groundhog Day storm from 1976, and this is just an animation of showing what the wave conditions looked like over a few tides during that storm, you know, around the Carver's Harbor area. So, you know, the other thing I just wanted to mention here is that we have already done quite a bit of analysis and modeling for Vinyl Haven, so we're not starting from scratch. I also wanted to point out that we did have recently, we just, you know, learned from FEMA that they have accepted a letter of map revision application that was applied for by a private property owner at the head of Sands Cove. And so I'm kind of showing here this is what FEMA's map in 2016. This is what it looked like in that area. And then when a letter of map revision is finally accepted and becomes official, FEMA puts out what's called a letter of map revision determination document. So if you're wanting to do a letter of map revision, this is your ultimate goal, is to get this document. And then that document includes a small map that shows a, you know, cutout area of the flood insurance rate map panel and highlights what the revision looks like. And so if you look kind of carefully here, we're looking at areas in here where the revised flood elevation is 10 feet, and the revised zone is in an A zone, an AE zone. And if you go back and look into some of these areas on FEMA's maps, they had mapped this area as a VE zone with base flood elevation of 18 feet. And so we see a pretty significant reduction in the base flood elevation, and this is something that you see in other places in the mapping in Vinyl Haven, where the because of the way FEMA chose to do their analysis, and I like to kind of describe it as they painted the maps with a really broad brush, and they did that conservatively, and so they ended up putting a lot of areas into this flood zone with high flood elevations that really shouldn't be if you do a more detailed analysis. And so with a LOMR, what we do is we do a more detailed site-specific analysis to really get a better sense of what that flood hazard should be. And in this case, just really it's just based on the physics of wave action and understanding what the water level could rise to in the ocean in terms of a storm surge. It's really just not even feasible that you could get waves this high. And so that's kind of what we're looking to do is do that more detailed, more site-specific analysis, paint with a much finer brush, and come up with a more detailed and more correct analysis of what that 1% chance flood looks like. So this slide's a little bit scary. But I wanted to put this in here just to kind of show what goes into determining the base flood elevation. And once you determine the base flood elevation, then those elevations are used to map the flood zone boundaries. And so this, I'm not sure if you can see my cursor moving around when I do this. You can, okay. So we start with, this is an elevation, and an elevation has to be tied to a datum. In this case, the new flood maps use this North American vertical datum of 1988. We call it NAVD 88. That's basically 0, and it's somewhere a little bit above mean sea level. And so, that's essentially your ground elevation. The ground increases. Obviously in other places it's higher than that, but on top of that, you have potential for the tide to go up and down. The tide, it changes hour to hour, day to day, month to month, year to year, and so that that increase in just tidal action can cause flooding itself. But then when you get a storm, you add storm surge to that. So that increases the water level even more above the tide. The wind blowing on the water, atmospheric pressure, a low pressure system moving over the water kind of pulls the ocean up. And so that increases the water level along with the wind. And then with wind, you also have waves, and waves do a lot of different things. The sort of mechanics of waves are very complicated, but we kind of look at waves as contributing to the flooding in multiple different components. And one of these is called wave setup. And wave setup is actually what can kind of be thought of as an increase in the mean water level. So if you have waves, it's caused by wave breaking. So when a wave comes to the shoreline and breaks, it kind of falls over and throws water up onto the land. That water piles up over many waves, and it builds up the mean water level just a little bit. And so that component then gets added to that tide and surge. And so those things, the tide and the storm surge and the wave setup, can all be calculated with these hydrodynamic and wave models, like we used for the vulnerability analysis study. So that kind of gives you this elevation. And then FEMA's guidelines require you to do two other calculations, to look at two other effects to determine the base flood elevation. One of them is called the controlling wave height. And this applies when you have flooding, that storm surge plus the wave setup is higher than the ground. It's over land. And so when the surge comes up over the land, now waves can propagate over the land. And FEMA has a standard model that's used called WAFIS. It's the Wave Height Analysis for Flood Insurance Studies model. that is essentially required to be used to calculate how high the waves would get on top of that water that's inundating the land. And so this is just showing an example of what the output of that calculation looks like. And this tells us, this model calculates the wave height and then calculates what the elevation of the peaks of those waves are above the ground. And based on that wave height, if it's greater than 3 feet, you have a V zone. Where it's less than 3 feet, you have an A zone. And then the elevations that come out of it are used to map the base flood elevation in some places. There's an alternative calculation that we have to do that tends to apply in areas where the land's not necessarily inundated by the storm surge, but you have waves impacting the shoreline, and when they do, they can splash up onto the shoreline and cause damage. And so that's called wave run up. And so there's other types of calculations that are done mostly using empirical equations. A lot of them are based on old model studies and things like that, to estimate what the height that the wave might run up to when it breaks on the shoreline. And so the wave run up tends to apply on steeper shorelines and applies in areas where the wave impact can be a lot higher than the mean water level. And so you do all those calculations and you come up with a wave run up elevation and a wave crest elevation. And then whichever one of those is higher in a certain location is the one that's used to set the base flood elevation. And all of this is done on top of this understanding that we're looking at a storm tide that would happen with a 1% chance in any given year, and a wave that would happen with a 1% chance in any given year. And so in order to have an effective LOMR application, you have to provide all these calculations to FEMA. You can take the calculations that FEMA did and revise them if there was something wrong with them, and submit that back to them, show that it makes a difference, show that it changes how the mapping looks. Or you can, if you follow FEMA's guidelines, you can do independent calculations using better methodology, better topographic data, and submit that information to FEMA. They'll review it, and if they agree that it meets the guidelines and it's been done correctly, then they will revise the mapping. So what are some of the deficiencies that we found when we reviewed the analysis and mapping for FEMA? So one of the big things is that those calculations, particularly the wave run up and overland wave calculations, are done along these shore perpendicular transects. It's a one-dimensional calculation that looks at how the waves and the wave action, the wave overland wave analysis and wave run up analysis is very sensitive to what the slope of the shoreline is and how it goes up and down as the waves come in, how the ground level changes. And so essentially those calculations depend quite a bit on what that shoreline, that perpendicular elevation profile looks like. And so we call these wave transects. And there are 8 wave transects in Vinyl Haven. FEMA has guidance that says that in areas where the shoreline is complex, these wave transects could be spaced up to a few hundred feet apart. In areas where the shoreline is more uniform, they should be spaced up to a few thousand feet apart at most. But what they've done in Vinyl Haven and actually throughout most of the state of Maine is they've spaced these wave transects much further apart than that. Some of these are miles apart. You can see here from this is a map that's taken out of the effective flood insurance study that they even in the shoreline data that they had that they may have used to determine where they were going to make these wave transects, they're actually missing part of the land of Vinyl Haven. So there's no wave transects in this area, and I don't know if that's because they just didn't know there was land there from the mapping that they had, or they just were deciding to, they didn't need to transect there because they were spacing them out pretty far. But as you all know, the shoreline around Vinyl Haven is very complex. It changes, the slope of the shoreline changes, every 20, 30 feet or so in a lot of places. And so a calculation that's done along, a wave transect right here might not give you good results that would apply to one just a couple hundred feet away. And so one of the big deficiencies here is that there's just the level of detail in the one-dimensional analysis is really lacking. And that's something that it's fairly easy to make a case to FEMA that if you do an analysis on a new wave transect in a new location that they haven't done, following their guidelines and using the acceptable methods, that you have a pretty good chance that they'll accept a revision. We also know that in some of the calculations that FEMA did, there are errors. This is just showing a page out of one of these MathCAD sheets that FEMA used, and MathCAD is a program that is used in the engineering world to do calculations that you can. It's a nice program that allows you to put together a worksheet to create a well-documented series of calculations, and you can put even almost like computer code in it with logic and things like that to do the analysis. In this case, we actually found this back in 2016 when we were working for the city of Rockland on an appeal of the maps there. FEMA has a sort of a template for this calculation that does wave setup, and they use that same template all throughout Knox County, and that we found that template actually has an error in the logic in it, and what that means is that in some locations where this was used, if the waves were relatively small compared to the depth of the shoreline, their analysis would, because of this error, would overestimate what that wave setup value is. And so, in some cases, it produces completely unrealistic numbers. And FEMA didn't catch this in their analysis. We caught that when we were reviewing the analysis for Rockland, and then pointed it out in the appeal for Rockland. FEMA then let us correct the mistake in the appeal for Rockland, but they didn't go back anywhere else where they had used this and correct the other mistakes. So they don't, unless somebody calls them out and says, this is wrong, here's the right answer, and this is how it changes the map. FEMA's not going to do anything about it. In this particular case, this is Transect 60, which is up on the north side of Vinyl Haven. The wave setup value that they calculated came out to be 2 feet. When we correct the calculation, it should only be 0.2 feet. So they're off by a factor of 10 on that. And if I go just kind of jump back, that's this component of determining that base flood elevation. So where that elevation is based on the wave crest elevation or the WAFIS results, changing that would potentially reduce the base flood elevation by up to 2 feet. Another deficiency that we see in the mapping is that, and this really comes down to is related to the earlier one where the transects are just spaced too far apart, but that FEMA would calculate the wave run up on a steep shoreline, and when the shoreline is steep, the waves can run up higher. Waves don't run up as high on a flat shoreline. But what they've done is they've calculated the run up on a steep shoreline, and then they came up with the base flood elevation based on that run up elevation. And then they follow with the mapping, they follow that elevation contour all the way around the island. And so that what that does is that tends to put large areas in the flood zone that shouldn't be. Because if a wave actually came over this land here that's a lot lower, it wouldn't be able to run up as high. And so that can put buildings and things in a flood zone that's much higher than they actually should be. And that's actually the case for the LOMR that I showed earlier at the head of Sands Cove. The mapping in that area was based on wave run up on a steep shoreline where the wave runs all the way up to 18 feet, 19 feet, but only traveling inland maybe 20 or 30 feet horizontally. But then they followed the elevation contour and mapped a much larger area where the ground elevation is actually a lot lower and the waves wouldn't be able to run up that high. So in the memo that we presented, we laid out this table, and actually FEMA, when they in the backup engineering data that FEMA has for the flood study, they put together a table like this. They call it the engineering summary table, or the Transect summary table, and it it just has a row for each transect, and it has some basic inputs to all the calculations, like what's the water level, what's the wave height, what's the period of the waves that are coming in, where did that come, what model or whatever was used to determine that, what's the slope of the shoreline, what's the wave setup. And so these things are all kind of laid out. And so we took this table and then just added a comment over here as to what we thought for that particular transect might be deficient that could be revised. And you can see the first 4 of them here that all had that error in the MathCAD sheet. And then there's some others here where we're not sure how they determine the wave height value that was used, which is another deficiency I hadn't made a specific slide for. But FEMA didn't do a good job of documenting how they came up with the wave height at the start of the transect for those transects. We really aren't able to figure that out. They used a model called ST wave to simulate waves. When we look at the output from the ST wave model that they used, we sometimes have a hard time finding at that transect what the wave height that the wave height that they actually used actually matches what came out of that model. And they have not done a very good job at all at specifying where they actually took those wave heights from. In some places, they may have taken wave heights from far offshore on the other side of islands and shoals that would reduce the wave height before the waves actually get to land. So that ignores that. And so the next set of slides are really just coming out of our memo. What we did is we looked at the flood zones that were mapped based on each of these transects, and then using Google Earth, we went through and tried to identify where we could see a building or structure, a roadway or something, infrastructure that was in the flood zone. And so this is showing Transect 60. This is one where we think correcting that error in the MathCAD sheet would reduce the base flood elevation by 1 foot. And you can see that FEMA mapped a very large zone based on this one transect. And so that correcting that mistake and then remapping this area, reducing the base flood elevation and remapping this area would potentially affect all these buildings and infrastructure that we found. I don't really know. We may have missed things. Some of these things may be, structures that nobody cares about. So this is really kind of a cursory look, but just where these push pins are is where we could see something in Google Earth. Transect 61. This is the area that was mapped based on this transect. I actually didn't really see much that was affected by this flood zone. So maybe it may be correcting it, may be able to reduce it by 1 foot, but that may not really have any substantial impacts. Of course, we may have missed something that's in this zone that someone may be aware of that they would be interested in correcting. Transect 62, we're kind of going counterclockwise around the island here. This is a similar story where there was an error in the MathCAD sheet, and where we believe that correcting that would potentially reduce the base flood elevation. And you can see the number of structures, things that we identified in this zone. Again, this is a really broad area, and this area is pretty sheltered. Maybe a little bit less sheltered where the transect is, maybe a little bit less sheltered in some of these other areas. So a more detailed analysis here is likely to show a lot more variation in what the flood hazard would look like, which, in some areas would even potentially increase it if you did a new analysis, but we really can't know that until we've done it. But an approach to a LOMR might just correct this transect and then revise this zone. Transect 63. I'm missing what my note was on this one. can see that. But I think we basically have a similar story here with the MathCAD sheet error. 64. This transect is the one that was used to map the area around Sand Cove that we revised with that other LOMR that I mentioned before. And the big issue here is that you've got quite a large area here with a lot of buildings in it that is where the ground elevation is above the surge level, you know, that 1% still water level, or the level that you would expect a storm surge to come up, and where overland waves could where waves could actually run over land for that 100-year event. But what FEMA did here is this is a pretty steep shoreline right here where the transect is, and they calculate a pretty high run-up elevation, and then they mapped the elevation contour here. And they've done some really kind of weird things with this mapping. We corrected this area up here, but down here, they extend this V zone really far inland where it shouldn't be able to extend, and they just they're putting a much larger area in the zone than really should be based on considering the topography. Transect 65. This is the one that's in Carver's Harbor. It appears that all this area that we see was mapped based on the results from this transect. We're not convinced that we understand where the wave height that FEMA used comes from here, and we think it might be too high. And then the other thing is that a lot of this area is not the shoreline here where this transect is drawn. Doesn't necessarily represent the shoreline around much of the rest of this area, particularly in the pond here. This one has quite a few buildings and infrastructure in it, as I'm sure you all are aware. This is another transect where the issue is a steep shoreline that was used to determine wave run up, and then the mapping was then drawn by following that elevation contour in areas where the shoreline's a lot flatter. We didn't see a whole lot of buildings that were affected by this particular transect, but there's a few. Okay, coming around toward Carver's Cove, looking at again the wave height here that FEMA used as the input for this transect. You know, there's some islands out here that would shelter this a little bit, shelter this area a little bit. But then I think we also have the issue here where this zone is mapped based on the wave run up on this steep shoreline. But as you go up into the cove, it just follows the elevation contour. But waves would actually not be able to run up that high in the cove. And for some of these other areas where the shoreline actually faces almost in the 180, almost in the opposite direction of where they did the analysis, where the transect's drawn. Quite a few properties appear to be affected by this one. And this is the last transect here. You know, in this case, there's a lot of areas that are in here that were mapped that are more sheltered than where this location is, and so the wave height may not be appropriate there. And I think that's the last transect. We also put together a table of you know, just where we tried to you know, just give a summary of what the recommendations would be and how we would go about it for these transects. You see for the first 4 here, just correcting that wave setup error. would likely show some improvement in the flood mapping. And then we've also kind of listed areas where we think it'd be valuable to evaluate additional transects to get a more detailed analysis. The correction of the wave setup would be a fairly easy thing to do. For the other transects, we think we really need to revise the offshore wave model that FEMA used, or develop a new one, which could be based on the model that we've already developed for the vulnerability study. And that is a little bit more involved, a little bit more effort to create a model like that. And then again, we have areas where we thought it would be advantageous to evaluate additional wave transects for the overland wave analysis and wave run up. And that's pretty much a summary of what we found reviewing FEMA's analysis. And I'm happy to take any questions, and I just want to thank you for the opportunity to present this.
Thanks so much, Nathan. Really appreciate it. We do have some questions that have come in, and I think because we're a relatively small group of people, if folks don't mind asking their questions verbally, I'm going to start with the ones that have come in that we've collected so far. If you want to continue putting your questions in the chat, we'll collect them, and then when your question comes up, I'll just ask you to address that verbally. And if you know who you want to address it to, whether it's Andy or Nate, or just sort of in general, that would be great. I'm going to go ahead and ask George if he wants to come off of mute and video and go ahead and ask his question for Nate.
Sure. So Nate, my question really had more to do with the location that I'm sharing on the screen right now. I'm looking at whether you have a drag coefficient when you're entering a narrow channel affecting the wave height and the flow. And I'm looking at your model the video that you showed earlier showed rapid attenuation coming up both Indian Creek and in Carver's Harbor. And so I'm wondering, the VE zone that is all inside Indian Creek really doesn't make a lot of sense when you consider all of the barrier islands, the bridge, the bridge abutments, the fill, and the narrow channel on Indian Creek. But that's a non-engineer asking the question here.
Yeah, I think you're absolutely right. It's hard to say whether it would be a V zone or not, or where the boundary between the V zone and A zone would be. When you if we were to analyze that, but the modeling that we did, that I showed that animation for, considers the physical interaction between waves and currents. The type of modeling that FEMA did doesn't. It's a steady state model, and it essentially assumes there are no currents. And so the way the waves interact with the tidal currents are not accounted for in their analysis. One of the things that can be a little bit sort of confusing about flood mapping, FEMA flood mapping in particular, is that we do map flood zones in a lot of areas that are open water, but the analysis is really designed to only give you estimates of what the wave height is over land, or the wave run up over land, and you don't see it on the newer flood maps, but on the older flood maps there was even sort of a disclaimer on it that says base flood elevations only apply landward of the zero shoreline. So which is interesting, because there, in some cases, towns and others use the wave data from wave data or base flood elevation data from FEMA mapping to make decisions about what the elevation of a pier should be, and for the most part, that's not, you're not going to run into a lot of trouble there. But there are cases where FEMA may map a V zone over an area of water just because it's a V zone on the shoreline there, but the waves may not actually meet that 3-foot criteria. And so it's but yeah, to answer your question, yes, I think you're absolutely right. Particularly in that area, I think if we did a more detailed analysis and we put a wave transect in there, and we looked at the wave heights to start at that wave transect, based on a more detailed wave model that included the current interactions, you very well may see that would be an AE zone. And I noticed there's a question in the chat about VE stands for velocity expended. Is this correct? I don't know what I don't really know what the V and A stand for, and I've tried to figure this out looking at FEMA guidelines. You hear them referred to as velocity zones. The E, I believe, means it's been engineered. It's an engineering analysis rather than an approximate analysis. And so the when you have an AE zone versus an A zone, the AE zone means it was determined by detailed methods. The A would mean that approximate methods were used. We don't see V zones anymore in the newer mapping. We just see VE, and that I believe the V comes from velocity, and I don't really know what the E means, but it's kind of a good question.
Thanks, George, and thanks, Nate. Chris, you had a couple of questions that it seemed like might be directed toward Andy. Did you want to ask those?
I was happy with George's answer, but I asked if there were a lot of properties that have been misidentified by FEMA. Is it up to the individual property owner to go to FEMA? I know it can be expensive to try to get that adjusted, or what is the town's thinking on this, especially now that we have this report?
Yeah, thanks, Chris. So I think that question is exactly a large reason why we wanted to have this presentation and conversation. The board in the budget committee last year had in front of them kind of like a proposal for FY21 to consider some funding at least for the Main Street. That's what the board was looking at originally, was just kind of the Main Street area, particularly the seeing that discrepancy on the north side of Carver's Pond is a VE, given all of the downtown and the downtown master plan work that was outlined. In the conversation, after we got the memo, kind of called into question, should there be more? We just haven't picked up that conversation until now, since that came out. So trying to, we need to try and figure out as a community, what is it, what is the community's appetite or desire to look at certain area or all of the island, given what the memo outlines. So I don't, there was no answer, but ultimately it comes down to the funding. As town meeting, dictates, that budget process, and what goes in front of town meeting for consideration, and how that vote is cast will determine whether there's funding to do the work. So George's answer there, is we know there has been at least one property owner successfully out here that's challenged a property they own. I know there's at least a couple others that seem like they're in progress or heading down that path on their own, and have also asked that question. So it'd be good to hear from property owners, Chris, or if other realtors here are hearing on behalf of property owners, but you can send those questions and continue those conversations either with me or at future board meetings.
Great. Can I ask another question, Gabe?
Definitely, yep.
Geared toward Nathan. I think there are 8 transects that you identified, and you went counterclockwise around the island of Vinyl Haven. Is there one along the thoroughfare? Because we started on the sort of very westernmost part of the thoroughfare.
Let me actually, oh wait, you're not seeing my screen right now. Let's do that again. So the first one that we looked at, 60, is the only one along the thoroughfare that's on the Vinyl Haven side. There's one on the other side.
Okay, I thought we started at 61, but I must have missed 60.
Yeah, so that's this one here, and as best we can tell, FEMA mapped this one large AE zone based on the results from that transect.
Okay. Thanks.
Thanks,
Welcome.
Chris. We have a question from Danny Burke. Danny, would you like to come off mute and go on video and ask your question?
Sure. Good evening, everyone. I'm sorry if we missed this at the towards the beginning. What are the odds of a new analysis being done and causing property that is not in floodplain now to become in floodplain?
So I think I can answer that. It's possible. It's possible that could happen, and one of the ways that we tend to approach these studies to address that is we take a phased approach. So we do an initial phase where we do the analysis, or maybe consider it kind of a preliminary analysis, to see what the results are going to be and how that changes. And if we see that, that the results are going to look favorable, then we'll go forward with the next phase and prepare the application, prepare all the documentation, and submit it to FEMA. If the results don't look favorable, then we often would just stop and not do that. But at the same time, the property owner and the town should be aware that that their risk may actually be a lot higher than the mapping shows. And so, we would want people to be aware of that. I think that, the one thing that I have to say about this is that, flooding happens outside of the flood zone all the time. A lot of times that may be because the zone was too low. And so people, you really ought to consider, every property owner has to sort of make their own financial decisions, but you really ought to consider whether it's worth purchasing flood insurance if you're outside of the flood zone. I think the general recommendation is you probably should have it, unless you're, on top of a mountain or something like that, where you know that there's very low risk. But there's flood risk everywhere, and when you're outside of the flood zone, if it's through the National Flood Insurance Program, flood insurance, I believe, is pretty inexpensive. Excuse me.
Great,
And
thanks.
I guess just to add to that, sorry. With the understanding that the FEMA maps are showing current climate, they're only showing that 1% chance event. Or when you look at the statistics on that, something you might have heard before is that over the course of 30 years, if you're exposed to a 1% annual chance risk, you have something close to a 26% chance of actually experiencing that hazard during a 30-year period. So typical 30-year mortgage, if you're right at the edge of the 1% flood zone, you've got almost a 1 in 3 chance that you would experience that flood, before that loan is paid off. And so the kind of understanding that likelihood gets accumulated over years. My recommendation is that FEMA maps, use them for rating the insurance and make sure they're as accurate as possible. But when it comes to making decisions about whether you should be insured, and in particular making decisions about future development and things like that, you really want to be looking at a more severe hazard. So you want to add some freeboard to that. Or, look at including what sea level rise might do. In 30 years in the future. Look at the 500-year flood, and unfortunately, the FEMA maps don't give you any of that information.
Great, thanks, Nate, and thanks for the question, Danny. So Aaron, I think you had a question for Nate.
Yeah, I do. I actually have a couple of questions. So do the type of soils affect the mapping? You know, sand versus bedrock versus, you know.
They do in some ways. I don't think there is any cases on Vinyl Haven where erosion has been considered in the analysis. But FEMA guidelines do require, if you have a sandy beach, a dune, or a shoreline that's erodible, it could be like an eroding bluff, that you consider a potential failure mechanism for that slope or an eroded profile. So you would do the analysis assuming there's not going to be any erosion, and then you also do it assuming there would be some erosion, and then look at sort of what the worst case is. We do have a couple of the transects on the island where it's not necessarily considering the soils, but structures, and so seawall or revetment structure, and the analysis does include, in a similar way, like you might have a natural bank eroding. It considers the structure in an intact configuration, and then also a sort of assumed failed configuration. And FEMA has some guidelines for how you make very sort of approximate assumptions on what a collapsed seawall might look like.
And settling or subsidation, is that the same thing as that's not the same thing as erosion?
No, the analysis doesn't take into account settlement or subsidence.
So in general, since we're not in an area of erosion, and we're on granite, are we looking at settling? I mean, I know that we're still dealing with ice age, settling, that type of thing, not settling, but the rising and the falling of the land. Yep. And that down south, especially, that's, because what is it, the cycle that it goes through from when the ice age? I can't remember. My husband telling me about it, and my son too, and I'm like, But are we dealing with that as much up here? That settling?
There is some, you'd call it, ground movement. I think that, and I'm not an expert in this, but that contributes to things like relative sea level rise. But for the FEMA mapping, and that's something that should be considered for, I think, for studies, for like a vulnerability analysis for planning for the future, and like we've done before, where we take into account sea level rise projections that include an analysis of those things. In this case, for the FEMA maps, they're really designed to represent the current risk today. Oh. So if those processes happen pretty slowly. I mean, they can happen very abruptly if you have something like an earthquake or a landslide. But for those, and those earthquakes and landslides are ignored from the FEMA mapping for the most part. Because those things happen slowly, we basically are using a sort of static picture of what the topography looks like, or what the ground elevation is, and it's in this case, it's pretty recent. The elevation data, the ground elevation data that's used to develop the mapping comes from, well, maybe not that recent anymore, but it comes from 2006, I believe. Maybe a little bit actually more recent here than it is in some other parts of Maine. But assume it hasn't changed much in the last 10 or 20 years in terms of whether the ground settled or not.
So just
sorry, I'm just recognizing that it's time. So real quick, that would be great. Thank you.
So if we're looking at historical photographs of like Main Street, and my understanding is Main Street has gotten built up over time, and therefore it'd give the appearance of it sinking from photographs, compare if you were doing a comparative, but a photograph isn't going to tell you like whether Main Street's sinking or not. I'm a Main Street business owner.
Yeah, I bet where that area has been built up and filled. you know, there's always going to be some settlement, compaction of the soil. Without having sort of detailed survey records, it'd be really hard to say what that is. You know, the flood mapping is based on, you know, what the recent elevations are from LiDAR data. You know, it's a fly over with a plane that shoots a laser down at the ground and it bounces back up, and they're able to get a pretty accurate elevation. Although that data can be off by up to a foot, I've seen in places too. So, you know, that's another thing that can be a reason to request a flood map revision, is if the topography is incorrect. And there are certainly more accurate survey methods. So if you were to survey an area, maybe using GPS methods or you know, optical methods, you might find that it's different than the topography that FEMA used that was based on LiDAR. And that could in itself cause a difference in the mapping of the flood hazard, as well as what the wave heights were over land and things like that. So that's something that in some cases may be worth considering. The other thing too is that I would have mentioned is that we've been talking about a letter of map revision, where that involves, you know, a reanalysis of the flood hazard and actually results in changes at the base flood elevation and the mapping of the flood zone boundaries. FEMA has another letter of map change process that's called a letter of map amendment, or a LOMA, which basically just requires a survey, an elevation survey. And that elevation survey, if the elevation survey shows that the ground around the building is above the base flood elevation, it effectively removes it from the zone, even though it may be mapped inside it. And that that's a lot more common than a letter of map revision. It's less expensive to do because it doesn't require as much effort. And that's something that can address issues where FEMA where the topography data that FEMA may have used to draw the map may not have been accurate. The other thing too is that a lot of times buildings are built on high spots on a property, and that high spot might be just above the base flood elevation, and there, you know, in the area around the building may be just above the base flood elevation. But because it's such a small area, when FEMA maps it, they can't draw a whole bunch of little holes in the flood zone where higher areas are like that, because it just doesn't show up on the scale of the map. And so sometimes they include areas that are above the base flood elevation, even though in the flood zone, just because they can't really map that much detail.
Great.
And a LOMA can take care of that issue.
Thanks so much, Nate. Thanks for the questions, Aaron. I am going to turn it over to Andy to close us out for the evening, but I want to also just give Nathan a big thank you for joining us, and also everyone in the Zoom room and on Facebook.
Yeah, thanks everyone for joining us, and Nathan for being with us tonight as well. Again, as you've saw through this, there's a lot behind this, a lot of data behind this, a lot for us to still answer. And so just looking for, you know, feedback now from those that have seen this, from others that maybe haven't, that you know of, that are interested, just to follow up with us, and to bring it at least to me, and if not to a select board meeting, just for us to hear from you, and get a better sense of where, you know, the community feels we should be moving forward. You know, whether it's an individual approach or a community-wide approach, either funded by the town or in partnership with property owners. So that's really kind of one of our big next steps, is figuring out how best to take that task.